Okay, in section 6.2, we're also going to take a look at graphs of decreasing exponential functions. And so recall an exponential function is of the form f of x equals a times b to the x. Well, if b is between 0 and 1, the function is decreasing. For example, f of x equals 1/2 to the x. We can rewrite this as 1 times 1/2 to the x power, where a is 1 and b is 1/2, and we can clearly see that the function is decreasing. So what are some points on this exponential function? Okay, why don't we select a few x's like -1, 0, and 1, and we're going to just substitute each x into this function. So here's my scratch work. If I raise 1/2 to the -1st, that's really the same thing as raising 2 to the +1st, and therefore the y value is 2. Okay, 1/2 to the 0 power is equivalent to any number raised to the 0 power, which is just 1, and then 1/2 to the 1st is still 1/2. We see these points -1, 2, 0, 1, and then 1/2 are on the curve. We can also see how this graph relates to the graph of, say, g of x, which is 2 to the x. Okay, so if you recall, this function passes through 0, 1, and 1, 2. And we end up with this curve that looks like this. Okay, so both of these graphs, f of x and g of x, are reflections about the y-axis. Another way that we could write f of x is 2 to the -x. Okay, and therefore if we see this negative, we know that there's a reflection, and we see the x values are changing, and if they change signs, this is a reflection across the y-axis. So let's take a look at an example. We're going to try to graph the function f of x is equal to 1/3 to the x. Okay, so we'll use a table and select some different x values. And I'll choose -2, -1, 0, and 1. Okay, so my scratch work, I'm first going to take 1/3 and raise it to the -2nd. And notice that's equivalent to 3 to the +2nd, or 9. Okay, if we raise 1/3 to the -1st, that is equivalent to 3 to the 1st, or 3. And then 1/3 to the 0 is 1, and 1/3 to the 1st is 1/3. Notice for each increase in x of 1, that the y value decreases by a factor of 2/3. The next y value is just 1/3 of the previous y value. So plot the points in the coordinate plane and then connect them. And the domain for this function is -∞ to infinity, and the range is from 0 to infinity. Notice that there's also a horizontal asymptote at y equals 0. And lastly, let's take a look at some transformations of exponential functions. So remember, the main types of transformations are translations, which are shifts of the graph, dilations, which are stretches or compressions, and then reflections, which could be about the x or the y-axis. And we should be able to tell these based on the given equation. Okay, so similar to what we did with quadratics or cubics, linear functions, square roots, any of the toolkit functions. For example, if f of x equals the absolute value of x minus 2, we would say that the graph exhibits a horizontal translation of 2 spaces to the right. So all this is the graph of the absolute value function shifted 2 spaces over. So we first recognize what type of transformation occurs. If it has addition or subtraction, we're going to think there's a translation. And so on number 1, it looks like there's a translation of the graph. Depending where the -1 occurs, this is going to be a horizontal or a vertical shift. So why don't we compare this to f of x, which is 3 to the x. And so the -1 is inside of the exponent. And therefore, we're going to say that this is a horizontal shift to the right, 1 space. Okay, so since we already know what the graph of y equals 3 to the x looks like, okay, just using a couple of points, it passes through a y-intercept of 1 and also the point 1, 3, and now we shift that graph 1 spot over and connect those points with a curve. In example 2, we're going to try to graph m of x, which is -2 to the x. We're going to compare this to a function f of x, which is 2 to the x. And so notice there's a negative, which means we're going to have a reflection of some sort. Notice where the negative appears. It's on the outside of the original function f of x, and therefore the y values are affected. So if the y values change signs, this is a reflection across the x-axis. Okay, so you can imagine graphing the function y equals 2 to the x, and then reflecting that over the x-axis. So now we have a point 0, -1 on the graph, and 1, -2. And m of x looks something like this.